Hey everyone, welcome back. Again, you're on the EdgeVerse Techcast. This is your go-to place for everything that you want to learn about NXP's software tools and enablement. This is built for developers working with our processors and microcontrollers. We also work with our partners for solutions. Today we've got a guest for that. My name's Kyle Dando. I'm one of your co-hosts.
And I'm Bridgette Stone, and today we're talking about a challenge that hits almost every embedded project sooner or later, and that's getting a device connected reliably, securely, and without spending weeks stitching things together.
Exactly, Bridgette. Whether it's Ethernet, Wi-Fi, you're trying to reach the cloud, or even a simple on-the-device web UI. Everybody's getting those connected devices where you open up and there's a way you can look at a web interface for that device. It can turn pretty easy solutions into a complex production headache. So we're going to bring in someone who lives and breathes this topic. Sergey Lyubka from Cesanta, the company behind Mongoose.
If you're building in NXP MCUs and you want a faster path to secure connectivity, embedded web UI, MQTT, TLS, or OTA updates, you're in the right place. Sergey, welcome to the EdgeVerse Techcast.
Hi, I'm Sergey Lyubka, an engineering director at Cesanta, the company that develops Mongoose, an open source, dual license embedded work stack.
Sergey, thanks again for joining us. We're excited to share what Mongoose brings to NXP developers, but first, we always start with the elevator test. Imagine you're in an elevator with a total stranger. They spot your company logo on your shirt and ask, so what does Cesanta actually do? You've got 2 minutes to make it click. What do you say?
Imagine you buy a smart thermostat or industrial sensor or medical device, and it has a little web page that you can open on your phone or computer to configure it, see status, update it, or troubleshoot it. So Mongoose is the communication layer that makes that possible. It's a small, reliable piece of software that the device makers put inside their products, so the device can safely talk to browsers and cloud services, like having a built-in front desk for the device. Why it matters? Building that secure communication from scratch is slow, risky, and easy to get wrong. So Mongoose helps companies ship faster, avoid security problems, and keep products supported for many years, which is critical when devices are deployed in the real world and can't be easily replaced.
All right, Sergey, you passed the test. I was on that elevator with you, and I fully understand what Cesanta does. But let's spend a little bit more time trying to get the listeners more details about what you're doing. Can you share a little bit of the history between Cesanta and NXP and the support that you've provided? Maybe what was your first engagement with NXP in the past?
Our history in NXP started on IMX applications running embedded Linux, where companies used Mongoose to implement on-device web UIs. For example, the web server component used in SW Update on IMX boards. Later, we expanded to IMX RT crossover MCUs with ready-to-run projects and joint enablement around web UI dashboards. Then added production features like over-the-air firmware updates, TLS secured communications, and MQTT-based cloud connectivity. Most recently, we broadened NXP coverage again with Ethernet-enabled MCXN devices like MCXN 947 and added explicit support for NXP RW612, Tri-Radio Wi-Fi 6 MCU.
All right, you've been busy recently trying to get Mongoose support for those new NXP devices. Can you go into a little bit more detail about what you're solving? What are you working on with those devices? What's the biggest issue?
In embedded networking, the most precious resource is RAM. Buffers for incoming and outgoing data, protocol state, queues, and sometimes cached content all live in RAM. And once you add TLS, the pressure goes up quickly because encryption needs additional working buffers and session state. If TLS is in the picture, CPU becomes the second big constraint too. Handshakes and crypto can be surprisingly expensive, so having enough compute headroom is often the difference between just works in the lab versus stable in the field. We've seen this play out a bunch of times. A customer picks a perfectly reasonable MCU with around 100 or 200K of RAM. Then later, the requirement creeps in. We need TLS, or we need a web UI, or we need a cloud connectivity. On paper, it still sounds doable, but in practice, it turns into a constant fight. Their business logic eats a big chunk of RAM, and suddenly they are trying to make reliable networking work with the leftover of 40, 80K of free RAM. That's when things get painful, tuning buffers, chasing weird edge cases, and getting stability that survives real-world networks.
All right, so that sounds pretty painful, and I think we're going to talk about how Mongoose provides a solution. But before we do that, is there another way that people tackle this memory crunch? What other solutions have customers come to address this challenge?
Yeah, so after going through that once, other customers made a different call and moved to NXP IMX-RT parts. They're still in the Cortex-M world, but with way more headroom, more RAM, more performance, and fewer compromises. IMX-RT are insanely powerful. A good example is the IMX-RT 1170. You get 1 GHz Cortex-M7 plus a second Cortex-M4 core with 2 MB RAM, which makes it a great fit when you want a reliable, secure networking with a solid embedded web UI and cloud connectivity.
Okay, Sergey, so if you're building a connected product, whether it be industrial, consumer, medical, and you want that secure communication layer, that's where Mongoose comes in. For listeners who are new to it, can you break down what Mongoose actually includes and what problems it solves?
Mongoose is a production-grade embedded networking stack for commercial devices, enabling secure web UIs, HTTP WebSocket, TLS, MQTT cloud connectivity, and firmware OTA updates that ship in volume and are maintainable for years. It's delivered as a single file, all-in-one drop-in that includes drivers, a TCP/IP stack, an embedded web server, an MQTT client, a TLS stack with no required third-party software dependencies. Mongoose runs on bare metal or on practically any RTOS. Implementing TCP/IP networking with Mongoose is easier than with any other solution. With Mongoose, you are not just adopting a code base, you are adopting a proven path to shipping and maintaining secure networking in a real device. When schedules get tight or odd bugs show up only in the field, you have a vendor that knows the stack end to end and can help you to get a stable release quickly. Then keep it stable for years with security fixes and practical guidance. With many other solutions, you often end up alone, stitching together multiple components, chasing upstream changes, and debugging edge cases without clear ownership. With Mongoose, you get one integrated stack and a team that stays accountable and available when it matters the most. To throw in some numbers and facts, Mongoose has been on the market for 22 plus years. Our customers include Bosch, Siemens, Schneider Electric, Broadcom, and hundreds of other companies, big and small. Mongoose even runs in space on the International Space Station by NASA.
Okay, we officially have it runs in space on the bingo card. I love it.
That's right.
Now, Mongoose is not only a great name, but the part people really get excited about is the Wizard. I know we're audio only, but can you describe what the Wizard does and what the developer experience feels like?
Mongoose Wizard is an online visual builder that turns Mongoose into a practical shippable solution fast. Because even with the best embedded library in the world, developers still need to understand networking, TLS security, and HTML JavaScript to build a complete device UI or a cloud integration by hand. With Mongoose Wizard, you generate both the backend and the frontend without writing a single line of application code. The main task left is a small piece of glue code that connects networking to your device's data and actions. The result is a professional-looking, polished web UI and cloud connectivity that is designed to be safe and secure to ship in real products.
All right, that sounds easy enough for me to tackle, and I'm not even a software engineer.
I think we should put it to the test, Bridgette. Next time you're in town, we'll get the development boards out for you. All right, Sergey. You described several applications just a second ago that benefited from the Mongoose connectivity. How does Cesanta help customers address some of the new CRA requirements that are coming down? I saw that OTA is an option enabled by Mongoose. So has Cesanta worked with customers to meet some of the requirements coming with CRA with regards to OTA?
Yeah, for us, the security is paramount. With Mongoose, companies adhere to the CRA since we implement the following practices. First, Mongoose repository runs a continuous integration test powered by GitHub, which runs through hundreds of unit tests on every commit to the repository. Our unit tests are built with modern address sanitizer technologies, which help to find security vulnerabilities early. Second, Mongoose repository is integrated into Google's OSS Fuzz, continuous fuzzer, which scans for potential vulnerabilities continuously. Third, we receive periodic vulnerability reports from independent security groups like Cisco, Talos, Microsoft Security Response Center, and others. In case of the vulnerability found, we act according to the industry best practices. We hold on to the publication, fix the software, and notify our subscribed customers with the private fix. Only then the CVE goes public. And fourth, some of our customers, for example NASA, have specific security requirements and run independent security audits, of which we get notified.
I am glad you asked that, Kyle. The more we learn about solutions for connected devices, our listeners need to know how CRA is being addressed. Thanks, Sergey, for the details on Mongoose. I know our listeners are looking for answers to this problem. Now for the easiest question of the episode. How do you suggest listeners get started? What is the best way for them to evaluate the Mongoose Wizard with an NXP device?
Just plug your development board into your workstation, then visit http://mongoose.ws and click on the big blue button that takes you to the Mongoose Wizard. There, select your board as a target architecture, the type of the project like plain GCC plus Make or MCU Espresso or VS Code, and click Generate to create a project. Build, flash, connect to the serial console for logs, and that's it. But I would recommend watching some videos first. We have a YouTube channel with thousands of subscribers. I'd start from the web dashboard on MCXN 947N.
Perfect. We'll make sure to add that into our episode notes. I believe, Kyle, and you are working on getting some of this into our application code hub. Would that also be a great way for listeners to get started?
Yeah, we are working on having project pushed to application code hub and hopefully have a follow-up on that in a couple of weeks' time.
Yeah, we sure will. I'm super excited to get that project in the application code hub. I think that the application code hub, Sergey, will be the quickest way for the NXP developers to figure out how to integrate Mongoose into their products. We'd also love to have you back on another episode. So once that project's available, we can really go through the fine details of that project.
Thanks again for your time, Sergey. Love the discussion.
Oh, no problem. That was a lot of fun. Thanks for having me.
And for our listeners, if you enjoyed this conversation, don't forget to like, subscribe, and turn on notifications so you never miss an episode.
And until next time, keep innovating, download Mongoose and figure out what it can do, and we'll catch you on the next EdgeVerse Techcast.